We are the University of Akron Human Powered Vehicle Innovation Team. I'm Hari.
I'm Matt.
I'm Luke.
And I'm Eric.
This year, our innovation concept is a speed variable steering stabilizer. Unlike conventional steering systems, this is a speed variable concept. The steering is stabilized by spring forces that depend on how fast the bike is going.
We created a prototype on the bike from last year. The springs are connected to the tie rod on one end and to the linear actuator on the other side. The linear actuator is controlled by an Arduino Uno that gets RPM feedback from an inductive sensor on the rear wheel. The springs are unextended when the bike is at rest and then incrementally tighten from there.
Using an accelerometer attached to the tie rod, multiple test rides were conducted to examine the motion of the tie rod. This chart summarizes how our innovation realizes the proposed benefit. We could clearly see a decrease in lateral deflection. The purple data shows our device when fully engaged. This, in turn, yielded shorter lap times, which was an added benefit that we did not expect at the outset. Failures that occurred prior to execution are extensively covered in our innovation report. Since submitting the report, we found the key unanticipated negative aspect is the delay and slow speed that the actuator operates with, shown here. In order to account for this, we programmed our code to record the RPM feedback in 5-second intervals and to have the actuator reposition itself every 5 seconds. As mentioned earlier, the extension of the actuator is based on the RPM of the wheel. Via our programming calculations, linear speed of the bike is converted to how far the actuator, and thus the springs, is extended. Due to the actuator's mounted orientation, the maximum extension of the actuator equals no spring extension. This working prototype validates that every component of the innovation is functioning correctly. Now let's check it out in action. This video shows the bike riding without any extension of the springs, simply operating without the innovation. Now add the innovation. The path traveled is much straighter than shown before.